Audio Jungle. 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 Audio Jungle.
Assalamu alaikum. This is your computer science teacher Sarfawad Akhtar Ansari. Now we are starting a new topic which is about the conversion from binary system to denary system. First of all, we understand that what is a binary system. So binary system consists of two numbers and we also used to call it base 2 number system. Base 2 number system. And why do we used to call it base 2 number system, or how does the 2 comes from? So in binary numbers we have only two digits, 0 and 1. That's it. With these two digits we used to call it binary number system, right? So we have couple of groups of bits, means binary digits, and then we complete our 8 bit or 12 bit or 16 bit, means there is no other third number except 0 and 1, right? So we used to make a combination of 0 and 1. Let's suppose this is a pair of 4 bits, 4 binary digits, right? So we used to call it nibble. And now if I add more 4 digits, means 2 nibble, then it becomes a byte, right? So we can say that 8 bits equals to 1 byte. We can call it 8 bits, or we can say that it is 1 byte. We can also distinguish that there are two groups of nibble, right? So we have the combination of 0 and 1. Now we start the conversion, but before conversion I must explain you that how do we do it, right? Now this is a table that you can see. Let me maximize for you guys. Okay, now as I told you in the beginning that it consists of two numbers, 0 and 1, and it has a base 2. So you can see that there is a 2 written in the chart, right, in the table. So there are 8 twos, right? For example, there is a group of bits 1, 2, 3, 4, 5, 6, 7, 8. We have 8 bits, right? Triple 1 0, triple 1 0. So they are the 8 bits. Now we have to place the 1 2 4 8 method over the bits. Now you can see I have numbered it 1, 2, 4, 8, 16, 32, 64, 128. Now this is a confusing part, that how does it become. So you have to focus on the digit 2. Let me crop this image for you so you can easily understand it. Okay, now you can see that there is a power of 0 over the 2. Okay, we use 2 because we are using the binary number system, so that is why we are using 2, right? And why there are 8 2's, because we have used 8 bits. Now when we place 2's over the 8 bits, we have to number it, means 0, 1, 2, 3, 4, 5, 6, 7. We start with a 0, right? And now what we do, we have to do counting of it. Now let me undo this image. Okay, now 2 multiply by 0. 2 multiply by 0 equals to 0, but we used to consider it 1. Now 2 ones are 2, 2 twos are 4, 2 twos are 4, and then multiply one more time because it has a power of 3, 8, 2 twos are 4, 4 4 fours are 16, right? And so on. So you have to multiply 2 with its power, so then it becomes 1248 method. If there are 4 numbers, then you will just place 1248. If there are 5 numbers, just place 1248 16. If there are 6 bits, then place till 32. If there are 7 bits, then place it 64. And if there are 8 bits, then you have to place all of these numbers on these bits. I hope you understood this point. Okay, now let's suppose I used to draw the table first. Okay, now I'm placing the bits in the fields. Okay, let me do the formatting of it so you can easily understand. Okay, let's suppose this is a group of bits. Okay, now I have to place 1 to 4 method. 1, 2, 4, 8, 16, 32, 64, and then 1, 2, 8. Now what I have to do, I have to focus the numbers which contains only 1, right? Ignore the number 0. Okay, now 1 to 8. Okay, I am okay, let's start with the 1. You can find 1 below the first row, right? So here you can see 1 below this number, so we have to focus only number of ones in the second row. Okay, now 1 plus in the second column you can see 2, and below 2 you can see this is a 1, so you have to see 1, but you have to write this number 2, right? Now in the 4 you can see 1, so you have to add the number 4. Now you can see the number 8, and 8 contains 0, so ignore this number, right? Ignore all the zeros. Now next number is a 16, and below 16 you can see 1, so you have to add 16. Now you can see 32, below 32 you can see that there is a 0, so ignore all the zeros. Switch to the next number 64. Now write 64. Okay, now next is 128. You can see number 1 and below the 128, so you have to write 128. So what you have to do, you have to sum up all these numbers, right? Whatever be the total number of it, so you may write. Let's suppose it becomes 400 or it becomes 250. The basic concept is that you have to add up the numbers which contains 1, right? Now let's suppose we have not 8 bits. The question is we have 1 2 3 4 5 bits. So what you have to do, you have to add up till 16. Like let's suppose you can see there's a 1 below 1, and then you can see below 2 you can see 1, so add up to. Now you can see below 4 there's a 1, so you can add up 4. Now you see below 8 there's a 0, to ignore it. Now switch to the next number 16. You can see the number 1 beneath it, so you have to add 16, right? Whatever be the sum is, it doesn't matter. The only thing matters that you have to add up the numbers properly. I hope it cleared your concept. Okay, now and another question arises in the mind of the students, that what about if there are more bits, right? Let's suppose it could be 12 bit, right? So how can we fit into this number system? So we have to double the current number, right? Let's suppose 1 2 4 8 16 32 64 and 128. This is a 8 bit, and let's suppose if there are more than 8 bits, 12 bit or 16 bits, so we have to double the current number, like 128. This is the current number, last number of our numbers. So the double of 128 is 256, right? It will be the 9 bit. Let me show you. Here you can see that there are the bits, right? 1 2 3 4 5 6 7 8 9 10 11 12. So we have to double the number. The double of 128 is 256, double of 256 is 512, double of 512 is 1024, and double of 1024 is 2048, and so on. You have to double up the numbers. Okay, now next topic is denary to binary. Okay, now let's consider a number 142, right? This is a denary number and we have to convert it into the binary. So we consider or this denary number that it must be 8 bits in binary form, right? It may be above 8 bits, okay, but this is an assumption that we can say that 142 is considered to be the 8 bits. So let's suppose we start with the 128 because it is bigger number. 128 plus 2, 130, right? Plus 8, 138, and then plus 4, then becomes 142. And what about these remaining blanks? We have to fill it with the 0. So in this form you may solve it and the denary number into binary. This is the method that you can find it useful. I hope you understand this concept.